Hello, everyone. My name is Uma. I am one of the facilitators for the course this semester. I am a third-year undergraduate studying data science and economics, and I'm going to explain what we have in store for the rest of the semester. This is our syllabus. We separate the course into three main modules, the first being data cleaning and analysis, the second, data visualization, and the third, data storytelling and presentation. So for our first module, we focus on being able to get raw data, and we ask ourselves, how can we gain insights from this raw data? Well, in order to do that, we'll be primarily using Python, as well as packages such as pandas and NumPy. And we'll be learning various statistical methods such as linear regression, hypothesis testing, and A/B testing. Then we'll end the module with our SQL lecture, where you'll learn how to query data and put them into spreadsheets. For our second module, we focus on data visualization. How can you highlight and show trends and patterns within your data? And to do that, we will be using Python packages such as matplotlib and Seaborn, and then different visualization software such as Power BI and Tableau. In our final module, we will focus on data storytelling and presentation, and really find out how to effectively communicate your findings to different types of audiences. Throughout the semester, we will also have panels to gain insight on what people can do with these skills. Where can people apply data cleaning in the real world? How do people use data visualizations in their work? And how do people effectively communicate what they need to communicate?
Hello, and welcome to this first lecture of Essential Tools for Data Scientists. My name is Kate. I am one of your facilitators this semester. I'm a fourth year studying MCB and data science. Ask me all your questions. I'll be available on Discord. More on that to come. All right, so some logistics. Our lectures will be released around 6:30 on YouTube. You're getting an email about it this week, but hopefully in the coming weeks, you'll be able to use our course landing page for all links. Those are links to YouTube videos and your weekly assignments. We've tried to really streamline things this semester, so it's as easy and low stress as possible. Your weekly assignment's going to be worth 80% of your grade. It's really simple, just going to be a review of the concepts from lecture, and you're going to work a little bit on your project as part of that each week. And attendance is worth 20% of your grade. And that attendance form can be found in the description of the YouTube video every time. So we're going to be using Discord for most of our communication this semester, and we figure that'll be like fun and more chill than Piazza, and we're a DeCal, so we can do that. All right, let's jump into Python. All right, so it's everyone's favorite first programming language. It's Python. Python is great because the syntax is easy, and it's useful for all data-related things such as scraping, cleaning, visualization. I have here a link to the demo. These slides will be shared with you and you can view it as well, but it's a link to a Jupyter notebook, which you will have seen if you've taken Data 8 before. But yeah, they're super cute and super helpful. Okay, first off, data types. The first is an int or integer. Integers, they're whole numbers. They're positive or negative. They're -1, 10, 119. There are a lot of integers. I'm not gonna say them all, but that is one data type. The next is a float. This is a floating point value. These represent real numbers. There are some examples below. There are even more floats, which is crazy. Next, we're going to talk about strings. Strings are technically a data structure rather than a data type. They're a little bit more complex, but we'll get into that. So for our purposes, let's just think of them as text values. They are denoted by single or double quotations. You can see that A uses double quotes while conciliatory crocuses uses single quotes. Doesn't matter. As long as you're consistent end to end, Python will know that it is a string. Now you might think of 789 as a number yourself, but if you put it in quotes, Python will think of it as a string or text value, which is kind of fun. Now, our last data type is a Boolean. Booleans are binary. They represent true or false values. They are often the result of comparator functions, which we will see at points during this lecture. And finally, we have these data structures. We're going to compare a NumPy array and a Python list. Python does not have a built-in array type. The biggest differences between NumPy arrays and Python lists are actually memory efficiency and runtime, but for our purposes, we're just going to worry about their operational differences. So over here, we can see two NumPy arrays. Both of these A and B variables are being assigned in these assignment statements to various NumPy arrays. This first holds integers 1, 2, and 3, the second 4, 5, and 6. We can see a difference here because we had to first implement this, we had to tell it to be a NumPy array, whereas a list, we just put some stuff in brackets and it's a Python list, and it's as easy as that. But our first difference we can see here, if I want to use this plus operation, that's actually a concatenation of two lists. Whereas in the NumPy array, I'm summing each element in a pairwise fashion. That's our first difference. And then there's some operations that are a little bit easier on NumPy arrays than they are in lists. For example, a NumPy array, you can do operations like raising each element to the power of 2 with this very simple line of code. Whereas this will give you a type error if you try it on a list. There are ways of getting around this. We will see it later. Alrighty, so some more stuff with arrays and lists. So for this NumPy array, we're going to start with this assignment statement here. I'm going to assign array 1 to be a NumPy array containing integers 1, 2, 3, and 4. If I call it again, this is all happening in a Jupyter notebook. You got to call stuff if you want to see it. I'll find this array 1, 2, 3, and 4 just like I expected. NumPy arrays have some built-in functions, including sum and mean. If you wanted to break down mean and write it yourself, it's super easy. You could just do array1.sum divided by len of array 1, which would give you the number of elements in that array. And that's the same as mean. Super cool. Let's talk mutation for a little bit. Mutation is the idea of changing the value of a variable. So things can be mutable or immutable. This list, for example, mutable. So we're going to start by assigning list 1 to be cat, dog, and raccoon. I'm going to take the second element, which is at index 1, because everything in most programming languages starts at index 0, and I'm going to switch it, I'm going to change it to ostrich. So I'm going to assign this index 1 element to be ostrich, and if I call list 1 again, that change is there. And now I can do the same thing with cat. I can remove cat from list 1, and we won't see a cat anymore. Conditional statements. These control execution flow, super important, super useful. Now, if, elif, and else make up my conditional statements, and if any, see, there's a conditional there. If any of the conditional statements following the if, elif, or else are true, actually, else never has a conditional following it because it's the default. But if the if or elif conditions are true, then the actions are evaluated. For example, I can set weather to be sunny. Here is my assignment with this single equal sign. This is now a comparator. So this equals equals is comparing the value of the things on either side. So if my weather is equal to sunny, then I will print, I will mow the lawn today. Apparently I will do without any eyes because if it's sunny, I don't need them apparently. If this statement is not true, else will be evaluated. And I will watch a movie today. So since the weather is sunny here, I will mow the lawn today. But since the weather is raining here and the same code applies, I will watch a movie today. And we'll see some more examples of this in the demo. All right, so we're going to take what we've done so far and apply it to this Jupyter notebook, which was linked earlier in the slides. So I'm working from this Lecture 1 Python Bootcamp. The link will take you here, and I'm working on this one, this notebook file. Okay, so first I'm going to do some import statements. Fairly, yeah, it's just functional. It's just to import this NumPy package. Okay. So also in order to run cells, I'm just doing Shift Enter, which works on a Mac and is a lot easier than going up here to cell and saying run cell every time. Okay, so first I'm going to assign my first variable to this integer 123. When I call this variable, it will print 123 in my notebook. Predictably, if I subtract 23 from the variable I just assigned, I will get 100. Python also can just be used like a calculator, so any arithmetic expression like this can be evaluated. I'll set another variable, this one equal to a string, and if I call this variable again, I will see the string. Now, strings you can treat a lot like arrays or lists in that they are they're indexable, which is why I said earlier that technically a string is not so much a data type as it is a data structure. So if I call the 0 indice, I will get the first element, which should be a lowercase b. If I take the length, I should get 8, which is the length of the string. Upper will assign everything in the string to uppercase, but does not mutate my variable. If I then replace e with u, this will again fail to mutate my variable, but that's okay. You can see that this replacement did not happen in all uppercase, so that makes a lot of sense. And I can also concatenate strings. I will see Cal space Berkeley here with this sum operation. Okay, so now I'm going to assign something a little more interesting. This is an array, my first NumPy array. So I can run it and you'll see this. Now I'm going to mutate it. So I'm going to reassign actually the third element to 7. So the 6 should change to 7 when I call array again. Yes, it did, good. And now my next variable is being assigned to this third element in this array. And so I should see 7 here. All right. And finally, I have this list, a list of 1, 2, or 3, or 4. I'm basically doing the same thing. I'm going to reset the first indice to 0. Yep. And call this first indice, it should be 0. Cool. Okay, this was actually the same examples on the slide, so I won't go through it again. Conditional statements. So this is just another example, basically the same as the slide. I set this variable x to 16. If x is greater than 20, I'll print x is greater than 20. If it's not, I'll print x is less than or equal to 20, and I should get x is less than or equal to 20. Yep. Okay. And our final conditional statement, we're going to introduce elif. So first I'm going to evaluate if. X is still 16. If is not going to be true. However, elif is going to be true. So I won't even get to this else statement. And we should get oh gee, we small. Great. Okay, so we'll come back to this after we talk about loops. Alrighty, so our last two topics, we've got loops and functions. So first of all, loops. There are two kinds of loops. There are for loops and while loops. While loops repeat an action while a condition is true. The thing we have to be careful of in terms of while loops, we can end up with an infinite loop if we're not careful. For loops, we usually use to iterate through a list or array. So here we have an example of a while loop. I start by initializing this I to be 0. And while I is less than 5, I'm going to print what I is, basically. I need to make sure this incrementation is really important. If I don't do this, I will remain 0 forever. This will never be false, and my while loop will go on indefinitely. Incrementation, important, kids. So we can see that at every iteration, I is increased by 1, plus equals does that. And I will end while I will continue while I is less than 5, and I will end when I is equal to 4. That will be my last iteration, because at this next iteration, I will be equal to 5 and no longer less than. This code does the exact same thing. For I in range 0 through 5, print what I is. You can think of range as a list of numbers. You give range a starting number and an ending number. But you have to remember that since this programming language increments with its first index equal to 0, we're never actually going to get to 5. We're going to go up to 4. So that's the important off by 1 consideration. These two blocks of code do the exact same thing. Finally, we have functions. So functions are blocks of code that can perform an action repeatedly. Super efficient if you're going to use this same method over and over again. So you have to start by defining your function. That's what def is doing. You're going to give your function a name, and your function will take in things called arguments. So this function is going to take in one argument. Now, num doesn't really mean anything. It's sort of descriptive for you as someone reading the code that this will be a number, but we're just going to use it as a placeholder for when we actually use this function and input something. So if num modulo 2 is equal to 0, return this number is even. Modulo is like division, except that it returns a remainder. So if the numbers divided by 2's remainder is 0, then this number is even. If not, it is odd. So this is a pretty simple function. Is even 2 is even. This number will output this number is even. Pretty standard. Alrighty. So that brings us to the end of our slides. Woot woot! You guys are Python experts now. Okay, so finally, let's do some loop examples. This while loop example is exactly the same as our other example. So I can run it, and you can see it's basically exactly the same examples on the slides. So not super interesting. So for these for loop examples, I'm going to iterate through a list. So this first example is sort of a special case because you'll notice that each element in my list is the same as its indice. So 0 is in the zero place and index wise. So if I index LT2, I'll get 2. So this is sort of a special case. So I'm using I in LT in sort of a special way because it is both the indice and the element. So if I wanted to raise each element in my list to the power of 2, which I'm not able to do just by doing this. So you'll see that this works, first of all, but if I try to do it just by doing this like simple arithmetic operation, I'll get an error because this is not something that lists are able to do. NumPy arrays can. Now, this is my way of getting around it, but I did have to use this kind of like special case of the element being the same as the indice. Now, in order to get around that, I can use range. So this is the same case actually, but you'll see that I'm only gonna go through the first 5 elements. So I'm only gonna get up to 4. So actually 5 and 6 should stay exactly the same. This is basically the same code. So I'll run it again, and you'll see that 5 and 6 didn't change. Now, the other way of getting around this, so I think I have 7 elements here. And now, okay, there we go. So now my elements and my indices don't match anymore, and this should still work. So, except that now I have to do this because I is no longer the element. Oops, 6 out of that. Oh, there we go. Okay, that was just a naming issue. Fun little live coding demo for y'all. I make dumb mistakes sometimes. Okay, so yeah, that's how we get around that problem. You can just use the range that's the same length as the list. You can also, this is sort of a fun thing, if you don't know the length, if you're just given some arbitrary list, you can always say that, and that will give you the same end bound, the end bound that you want because it's the right length for the array. Okay, and finally, now we have some if statements embedded in our for loop. So for I in range 0 through 10, if I mod 2 is 0, print I is even, else I is odd. So this is sort of like a combination of multiple concepts, but that's really all it is, not super exciting. Okay, so now we have a character list. So we're going to iterate through this character. And if it has this hash mark here, it's just commented out. So if I uncommented these just notes, then this cell would error. Okay, yeah, this is just a little side note about concatenation. So if I have this character list, I can initialize this word to be an empty string. And okay, so word is just a variable name. I want to make sure that's clear. And for every element in this character list, I'm going to add it to this empty string. And then at the very end, after I've added all the characters in the string to the word, I'm going to print the word, basically. And I should get cat. Yay! Anyway, so that's a little fun concatenation of a list of characters into one word. Okay, and finally, just a little note about break and continue. So if for some reason I want to exit early, I can do this in a for loop or a while loop. If some condition is met and I want to exit early, I use break. So I want to stop iterating if I hit Twizzlers. That's basically what this is saying. So for every element in candies, if the element is Twizzlers, stop now. Do not continue. I hate Twizzlers and I never want to see this list again. So that's what this code is doing. Good. I only get Skittles and Snickers. What if I didn't want to just like discount the list entirely because it had Twizzlers? Maybe I'll just skip over Twizzlers. That's what continue does. So if this statement, if some iteration of this for loop makes this statement true, I will skip over it. So you'll just see, after running the cell, you should see Skittles, Snickers, Kit Kat, and Twix. And you do, because I skipped Twizzlers, because I'm not a fan. And finally, we have functions. So this is exactly the same as the example in the slide, except I changed like the output a tiny bit. So that should be fine. It doesn't output anything but this will, because now I am giving the previously defined function an argument. So this should say odd. Yep. If I change the argument, I can do that. Should say even. Fantastic. And then this final function is an absolute value function. And so the absolute value of -8 is 8. And I can change this to whatever I want. And that should do it. Now, abs is a built-in Python expression, and we got that from importing math at the very top. Okay, I hope this was super helpful, and I hope you enjoyed our first lecture. I know it was a whirlwind. Please ask us any questions that you do have.